This is my part of section 3, control in design interpretation. So we are working on textbook, and chapter 4 is under coverage now, and that is a reasoning. So once in chapter 3, once the design itself and design knowledge has been represented inside the computer, somehow stored in a computer, right? Represented, stored. So we have a knowledge base already. Then we can use them for reasoning. Right? Reasoning is, so here we are working on chaining of knowledges to produce answer to questions. Chaining of piece of knowledges. Knowledge inside the knowledge base, there are so many knowledge pieces, very similar to database. Inside database there are lots of data pieces. We are utilizing those data for something, right? There is a, we call it database management system. Very similarly, knowledge base system. We store knowledge pieces into the knowledge base and then use them to answer to any questions. That is we call reasoning. Right? So those two pieces are main components of the knowledge base design system. The other is applications and background. So in reasoning, we see already issues and also meta-knowledge. Control is similar to meta-knowledge. And today I will cover the control as a design interpretation. And next section can be covered by Younggi, and then that is talking about actions. Control as actions, and expert system is combining together. They can develop a software called expert system. And here we are also talking about shapes and object, because we are talking about engineering system. Application of reasoning or knowledge-based system for design, and monotonic reasoning also is coming again. So in section 3, we started already by Hala last time, backward chaining and forward chaining. And also we will see that what is goal-directed forward chaining. So this one is shown already the other time. Anyway, so chaining is connecting pieces together, right? Chaining. So rule chaining or knowledge chaining. Here they are saying fact and rules are combined to arrive at conclusion. That is similar to what is it? What is the 3 reasoning mode? Deduction, abduction, and induction, right? And forward chaining is similar to what? And backward chaining is similar to what? Can you remember? Somebody? Which one is similar to forward chaining? Which one is similar to backward chaining? This is similar to backward chaining. And forward chaining is, let me see. Right, forward chaining That is a little bit different of my. The other day, I explained this one before, but this example is a little bit slightly different from my explanation before. Anyway, deduction is trying to interpret, right? Interpret. So whether this one will be collapse or not collapse, right? While we are applying something, right? So that can be the conclusion. That can be the conclusion. But this one is used another thing, right? Conclusion can be here, right? Conclusion is here. Conclusion is here. But they use different terminology for this. Fact and what else? Fact and rules. And what is another component of our reasoning box? A table. I can't remember this. When we explaining these three reasoning type, we use three different items here, right? Fact, rules, and conclusion, or not? We do not use conclusion. Can you remember the table? What was there inside that? Result. Let me find out. We see many times, right? Many times. Okay. This table. I'm saying this table. Result. Okay, you're right. Result. Okay. So we say fact, case. There is a case. So the case and rule and result. Okay. Case and rule and result. Right. So we use these three components and three reasoning types here to make this table, and then return back to this forward chaining, backward chaining. And for the chaining, they use rule and fact and conclusion. Conclusion can be result, right? And then backward chaining, they use in this drawing, they use different wording. But we can say the goal is result, and then it can be a case. Okay? Do you agree on this? It depending on the situation, they use different wordings. Right? Depending on the problems. So backward chaining is trying to decide whether we want to prove that interpretation in terms of interpretation, we want to prove whether this result can be true or not by using our rules or theories. So backward chaining can be similar to deduction, but the case is not correct, not perfectly matching to that my reason. Anyway, in this case, when we try to go case and rule and arrive at conclusion. That gives my reasoning on another day is different from this. Let me check this one again, and then I'll show you next time. This one gives you my reasoning in different way. Okay. Let me return back to this one. Right. So anyway, this is a general idea of what is a chaining of rules or knowledges. Right? This is already explained by Hannah last time. Right? So here you have a division of rule base and database. Right? Inside database, they have a known or true fact. And this is a rule base. There is a pieces of rules or knowledges. Rule is a simpler type of rules. Right? So we start from here. If A is true and B is true, then we can say C is true. Right? But we don't know yet because whether B is true, right? Because this is not defined here, or asserted by here. So we find out the rules that can be used to say that B can be true. So by using this rule, finding out this rule, we need to check whether those two are true. But this one is asserted by this fact base, but the other one is still not working yet. So we need to find another rule to find out whether this is true or not. So from the knowledge base or rule base, we find out this rule, and then finally this is solved out, right? Because those two both of them are true, asserted by this fact base. So by chaining, we finally arrive at this one is true. So in this case, we see this one as where we started from. If we started from here, we can say this is backward chaining. So starting from result to arrive at whether this is true or not. We need to chaining several rules. How many rules we don't know, but chaining and arrive at the conclusion. Conclusion means whether this one is true or not. The C there, C. And this is another view of this similar one. And the same chaining, but in different view, right? So we started from in the last slide here, right? Slide here. But we want to know whether this one is true or not. But by seeing this is fact-based. Fact-based means those facts are true, already true. Right? We know this. So this one is asserted already, but we don't know yet this one. So we start finding out rule base to arrive at this rule. And then if this one is true, then this can be true, right? But we don't know yet. So we still find out this one is true, but we don't know yet. So in this way, we go this way. Or we may start from here. Right? We may start from here. But we don't know whether to go. So usually we need to have starting from here. That can find out chaining rules, finding out rules. Right? Otherwise, from here you cannot see which way to go. Right? So this one may be true, and then this is true. But then what? We don't know it. Right? We don't know how to progress from that point. So we'll see how the forward chaining is working. So backward chaining. Start with a statement, a goal or result, right? Goal or result. We can write down. That constitutes an interpretation of the design and attempt to determine whether it is true. So, whether this pipe will break, right? I want to know whether, by applying 100 kilogram on this. Right? 100 kilogram is too much. Say 10 kilogram. Say 10 kilogram. And attempt to determine whether it can be true. Right? Break is true. So we determine its truth by matching it against the consequence of another rule in the knowledge base. So we start with the chaining. You just see that before, right? See, starting from here, whether this is break. So I want to see whether this is break, conclusion, or goal. But we don't know yet whether B is true. If B is true, then it can be true. Right? So we started from chaining, finding out rules there. By matching, by chaining, matching, finding out. Right? So precondition. See, right? So precondition, there are two preconditions. So preconditions of the rules constitute of subgoals. So if this one is true already, then this is okay. But this one is not yet. So it can be another subgoal. We need to find out whether this is true or not. So it can be a second subgoal. So to find out whether this is true, we need to search a knowledge base. This process is undergone recursively until any subgoals match the factors. Any subgoal match the factors. Here, so by going in this way, finally we find out those subgoals or preconditions are asserted by factors. Then the other things are matched up by chaining. This is an example they use in the textbook to show the geometry underlying a rule for determining whether a rectangular is inside another rectangular. So first rectangle is inside second rectangle. Right? Well, how can we prove this? We see this already, but by using only computer and numbers, we need to check whether whether all the edges are in the other way, only one single directions. four of them have same dedicated directions, then we see this. So backward chaining from a goal state, whether this is broke or not. And then in this case, this subgoal, this precondition converted into subgoals here. And subgoals and goes into another subgoals, and finally they match all the facts. So that these are chained into arrive at the conclusion. Forward chaining is a little bit different. So they started from a set of known facts, and new facts are inferred using known facts. But they arrive at all they can find out, because there are no directions. We don't know whether to go. Right? So find out all the facts that can be inferred from a given set of facts. So it can be said as an exhaustive search system. All right. So this is the same as the example case of inside. But that use primitive of line and rectangle cases. What is difference? This is same. Right? Same. So H 4 points. H line. Probably this one is XY. So that it defines 2 points. So it can be a line. That is my guess. And then gives you a rectangle by defining components of four lines. Right? 4 lines. And then see whether the components of 2 rectangles can be defined as inside or not. But see, by using facts, you can arrive at any new fact that can be asserted by this starting point of facts. But we don't know yet. So so starting from A here, over here, they arrive at any deferred fact using the given fact space. But it can be growing explosion. It can be grown into convergence. Right? We don't know. So that is depending on the problem. But in this case, they show that successfully or fortunately, they arrive at some wanted conclusion there. Right. So in terms of by comparing the forward chaining and backward chaining, forward chaining is good for fact base and the knowledge base, from which there are many facts, and few possible conclusions. Right? Conclusions based on given fact. So when the problem type is going in this way, this is good for the chaining. Right? But a system, there are few facts and many possible conclusions, diverging cases, then backward chaining approach can be better. Say, the problem of, what was the name? Finding out the root finding out to the precious materials there. Right? In this case, or we want to go to the Busan today, right? And then what can be the good way of using forward chaining or backward chaining? Right? In that case, backward chaining can be better, starting from the goal state and trying to find out to arrive at this position. But there are different types of we'll see. It's a little bit different. Anyway. So we can explain this one again, that starting from fact base, applying rules, and then they try to arrive at any possible conclusion sets. There is a forward change. Any. And backward chaining is trying to find out whether this goal state is true or not by using rules and fact base. Sometimes this fact base cannot be proven by using fact base, so then it can grow into another subgoals. So we need to find another rules and chaining can be started. So in this way, I can explain this one. Any question on this? All right. So now, because of that efficiency problem, statement here, they want to combine those two things together. Right? So this one, you can say another way, top-down approach. I explained this one the other time. And bottom-up approach in system design. Right? So top-down can be backward chaining and bottom-up can be forward chaining. But which one is good? Which one is better? It's depending on the system or problem type. Once again. So sometimes when you have a very complex system design, you need to have both approach together. You need to use both approach in the other way around many times. Right? So that is very similar to this goal-directed forward chaining. In forward chaining, unnecessary effort exercised to establish the truth of proposition that turn out to be unrelated to any goal state, goal proposition. So bottom-up approach, because we don't have any direction, we arrive at as many possible conclusions, right? But some of them can be useful in the final stage. Some are not. So that is explained here. Unnecessary effort has been exercised. So we may be desirable to determine that two final stages. So the gold mines over there, and Busan city is over there. See, Daejeon is here, right? So top down or bottom up can be combined together. So whether these are connected, there is some connection between two facts. Busan and Daejeon, before using real action, to proving the proposition. So this is very similar to a generation test or pruning. Pruning can be this one. Pruning is general terminology of pruning of tree, right? So here they pruned up, especially this branch. Right? This branch is pruned. Yeah. So that after 1 year or 2 years, this gives you a more balanced tree. That is the idea of real-world pruning of plant. So that gives you very similar in pruned rules. So sometimes it can be in the tree. This is data structure tree. So this one can be eliminated from the full exercise at the beginning, so that we can reduce or we can increase the efficiency of it. So this one, it shows a goal-directed forward chaining. So you can see that there is a goal state over Busan or something, and we started from here. And then there can be many possibilities. But this branch is not valuable at the final stage, but we don't know whether this one is. So they just check whether there is some connection between the goal state before we exercising the full effort. That is the idea. Very similar to combining top-down and bottom-up approaches together. And control of actions, the rules, this is a rule, right? Rules can be used as action. Action is something working, right? Activity. And then production system, and also they are talking of scheduling. These are related. And also area of focus, and then reasoning of actions are used. So this is an example of bottom-up reasoning and interpretation. So they started from small geometries of lines and edges and points, and then they find out their relationship between geometric primitives. This is one example. And start from with the fact base, the bottom-up approach. We match the precondition of each rule, preconditions, and then arrive at some another tentative conclusions. So that we call this forward chaining. And backward chain is reverse way. We started from check whether this is true or not. Right? Consequence matches and chains together. And rule becomes application. If some rule is applied, matches, then we say this is a new fact is asserted into the fact base. That is showing this case. Where is it? Right. We said this is a asserted fact. D, B, C is asserted fact. This is a given fact at the beginning. This is an initial fact. That is, they are true, right? But by using these rules during our reasoning stages, these cases can be found as true, right? So we call this is asserted fact in the middle. And then that gives you this statement of asserted consequence into the, so they are put into the fact base as a new true fact. Right? And then we see this fact basis grows as we exercising reasoning. So that we see this is a kind of action. Action means they change the status of fact base by using action. Or they are saying action as a firing of rules. So production system is coming in this way as action and firing and changing the fact bases. So task of production system is, so production system is similar to expert system in later stage. Is transforming or changing the fact base from initial state, initial given fact base, into enlarged, increased state of fact base. So there is two choices of cycle. There is action and instantiation. And then the rule, we should find out rule. So we rule should be selected. And we see that there are two preconditions. And then if that they are matching into the fact base, then the conclusion, consequence can be said as true. And then it can be, we see the rule is fired, rule firing. Because it is precondition, first we should find out select the rule and try to match the preconditions, and then finally we fire or arrive at the consequence. All right? This is a production system, or say expert system configuration. And there is this is a knowledge base, rule base, I can say, rule base. And this is a inference engine, or control, or reasoning engine. And there is also database. But usually we are saying the knowledge base and reasoning system. But also the knowledge base include fact based. All right, once again, the forward chaining. And they are saying breadth first search in a production system. Depth first search and breadth first search. Have you heard about this one? Right? So in a tree, this is tree. In a tree, I'll show you some tree. Data structure is made of tree. But let me show this one. This one can be a not good example of tree. But anyway, a tree. A tree is this one is true. A tree, right? When you trying to find out this node, right? This node, somehow, I want to find out whether there is how many people are living in Daegu city, something like that, using a database of Korea population. But computer need to find out this path, but we don't know yet. So computer is trying to search all the nodes. But there are two different approaches. Breadth first, or depth first. Depth first. So we call this as depth first search, or the other one is breadth first search. Right? There is two different strategy of using or searching But here they are talking about breadth first search rather than depth first search. This is very common wording in data structure system, but in a production system is explicit. Okay, how many slides are remaining there? 5 more. Scheduling. Schedule is an ordered list of events. Right? You have a schedule, calendar, right? Ordered list of events, and events is at the top of the list is to be activated first. Right? First one comes first. So after 11 o'clock, lunchtime, and I should go to a restaurant, and 1 o'clock there is a class and another class, right? The schedule is ordered. The sequence is important, right? And activation. And event is a combination of action and instantiation. And action is triggered when it is precondition can be action, right? Matched against the fact base, and the firing, right? The triggering and firing. It's triggering and firing is same as a gun. So they use wording as action in production system. Rule as action. This is just a scheduling diagram, sample of scheduling diagram. So there, once again, the sequence is important. Timeline is important. And focus of attention, area of interest. There are 2 different ways of partitioning the fact base. So searching, once again, searching, breadth first search or depth first search. Which one to search? When I try to find out Sunjoy while I'm searching here, my image analysis, right? Image processing, I should find out and focusing the area of this picture. Right? We call this area of interest. But by partitioning this image database into, so among this slide, you should find out where is a wording neighboring. Then you should arrive at this point. Right? How do you process this image? By using your eye and brain system, or as a robot system. Right? So they have a partitioning, the image base, and there is 2 ways that using a tree system or using a joining system. Right? Depending on the problem, you are using this. So spatial partitioning is joining, right? So it's a neighboring structure or samples. UML is in object-oriented programming. Object-oriented programming. There is a method to have a unified modeling language, kind of language. You use this language for handling the object-oriented object space. And they have different ideas inside the UML method. This is a language or method. One of them is activity diagram. So this is very similar to scheduling. Right? So activity diagram I showed to say that this is very similar to flowchart. Right? Flowchart. So I want to just see the scheduling and event sequence, sample cases. So, okay, this is final slide. And actions. Reasoning, right? Action is here saying a firing of rule. Right? Firing of rule is, they are saying action in production system. And reasoning, and there is a selection among competing rules. You can say rules. So you need to find out the correct rule from knowledge base, rule base. There are million rules inside. There can be a billion data in a database system. How do you find out the correct one? Right? So it is a searching system. So partitioning or organizing the rules, and also you use features coloring or shaping or other special points to use for the identification. Sometimes you use domain-independent knowledge for the selection between computers. Right? That's it for. It takes a longer time than expected. Question? No. Okay. All right. Go on to Hindi.